Alright, grade 11s, these are just some slides on grade 11 trigonometry. I'm going to be breaking it up into the different sections that come with trig. So the first part I did revise in the first video, so please go onto the YouTube channel and watch that first video revision of grade 10 trig. Alright, so now to go into the grade 11 stuff, I just want you to work with me, so get your calculators out. Alright, so once you've got your calculators out, make sure they're on degrees. If they're not on degrees, then click onto your shift setup, so your shift mode button, and then find your DEG or degrees. Alright, then I want you to type in your calculator as if beta, the angle beta is 32 degrees. So for A, it's sine 32. So sine 32 in my calculator gets me, and we're going to round it off, okay, to 0,5299. Let's leave it at that. 99. All right. Then you're going to do the same thing with cos beta. So cos 32 degrees in your calculator is going to be 0,8480. Right, let's just keep 4 numbers there. Then if you type in tan 32 degrees in your calculator, I'm getting 0,62487 if I'm rounding. If we're keeping 4 decimals though, we'll go to 49. All right. Then I want you to type in your calculator sine squared beta plus cos squared beta. So now sine 32. So your calculator will automatically open up sine and then a bracket 32 degrees. You then put the square on the outside. And then you add cos and it opens up a bracket 32, and then you put the squared on the outside. And that should give you an answer of 1. Okay. Then I need you to open up your fraction button, right? And I want you to type in your top, in your numerator, sine 32 over cos 32. And it gets you to 0,6249 if we round off. And hopefully your brain says, hey, I've just seen that number. It's the same. So we have already found a bit of a connection here, that tan of an angle is the same as sine of the angle divided by cos of that same angle, sine beta over cos beta. We've also kind of learned a rule here that if I take sine squared of an angle plus cos squared of an angle, I'm going to get an answer of 1. If you try it with another angle, if you said sine squared of 40 degrees plus cos squared of 40 degrees in your calculator. So again, sine, open bracket 40, all squared on the outside of the bracket, plus cos of 40 all squared. It gives you the answer of 1. So that's another rule. So we are going to talk about these rules. These rules are called identities. Right, and here they are. So your general rule is tan theta, or tan of an angle, tan x, tan beta, is equal to sine of that angle over cos of that angle. Right, so that's your first rule. But then also, sine squared of an angle plus cos squared of that same angle will give you always an answer of 1. Now, this piece can be manipulated. We can take the sine squared over right, and we get cos squared is 1 minus sine squared. Or we could take, let's just do that. Or we could take the cos squared over, and we end up with sine squared by itself, and 1 take away cos squared. If we don't want them squared, remember we're allowed to square root both sides of an equation, so it could become plus minus. You very seldom use these second two rules, but it's always handy to be able to recognize something like that. Okay, so when you have sine theta, you can replace it with plus or minus because of the square root 1 minus cos squared, or vice versa. You're given this ugly square root in a question, you can change it to the better ratio, sine theta or cos theta. But your main ones that you're going to be working with are the 1 and 2 from the top, as well as manipulating these first ones, A and B. All right, so just that's study work. You need to get that. It's theory. You must study a tan is sine over cos. Sine squared plus cos squared equals 1. They must have the same angles, though. So if it's 40, it must be 40. If it was 32 from the previous slide and 32. It won't work if you have different angles. All right, then on the next slide, I'm just going to show you where these identities came from. They come from your right angle trig. So if you have your setup in a normal triangle with your x, your y, and your r as shown, your sine would be y over r, because remember we're working with opposite over hypotenuse for sine. And your cos will be adjacent over hypotenuse, which is x over r. All right, so bear that in mind, and I have then made the y over r in red, and the cos is x over r. So if I were to divide them in order to make tan, so sine over cos would be the red over the green. Now if we take this y over r divided by x over r, remember we can tip and times. Our r's cancel, we're left with y over x. Now we know y over x is opposite over adjacent, which is our tan. So that's why sine theta over cos theta will get you tan theta. Okay, so that's the proof of that first identity. Then the next identity is the sine squared plus cos squared. So if I were to take sine squared plus cos squared using these ratios that I found, so y over r all squared, x over r all squared from the green and the red above. All right, I can actually work it out. They have a common denominator. It can be x squared plus y squared over r squared. Okay, so once I distribute the squared in, so y squared, r squared, x squared, r squared. So they have a common denominator of r squared, so we can combine them. But we've learned before that Pythagoras says that x squared plus y squared equals our r squared. So instead of that top bit, we can then make that r squared at the top. So this blue piece here at the top is Pythagoras, so instead of the blue piece, I can replace it with an r squared. But r squared top and bottom is equal to 1. So sine squared plus cos squared equals 1. And that is your second identity. This is just theory that you must know. They could ask you to prove the identities, but it's not a very common question. Normally they just ask you to work with them. 9 times out of 10, you just work with the identities. All right, grade 11, so just bank those identities to one side. That's just one concept now. So you've now learned a rule. Sine theta over cos theta is tan theta. And just on a side note here, if you had tan squared theta, it would be equal to sine squared theta over cos squared theta. So you can also manipulate like that. Also, if you're working with sine squared plus cos squared, you'll get the answer of 1. Okay, so just bank that information. We're moving on to the next concept now. So in your calculators, I want you to fill in all the numbers on this table. Now, I am going to post these slides up onto the Google Classroom. but I'm also just going to pause, fill them all in. So take the time, pause first, fill them in for yourself, and then see. All right, the first column is angles between 0 and 90. Second column, 90 to 180. 180 to 270, 270 to 360, and then greater than 360. All right, so I'm just going to pause, fill them in, and then you have a chance to fill them in. So pause now as well. All right, so here is your table of values filled in. If you are working with your calculator in degree mode, then it will work out. If it's not in degree mode, then you're going to get weird answers. So please check that again. Then I've just rounded off to 2 decimal places. Let's have a look at what we notice here. I notice that all of these have the same answer, except for some are positive, some are negative. All of these have the same answer again, except some are positive, some are negative. And likewise for the tan. So let's try and think of what the pattern could be. So between 0 to 90, all of our answers are positive. Between 90 to 180, only sine is positive. Between 180 to 270, only tan is positive. And from 270 to 360, only cos is positive. And if we start again, greater than 360, they're all positive. So this should hopefully jog a memory of something that we've spoken about in the previous video, and that is your cost diagram. So all students talk crap, so all are positive in that first quadrant, 0 to 90. From 90 to 180, only sine is positive. From 180 to 270, only tan is positive. And from 270 to 360, only cos is positive. Now, once I go greater than 360, I'm actually starting a new revolution, and so it ends up in the first quadrant again. That's why they were all positive. So this table is representing the cost diagram that you're used to seeing, where certain numbers will be positive in certain quadrants. And I did explain this and recap it in that first grade 10 revision video, so please go and have a look at it. Now, to discuss the issue of why sine 42, sine 138, sine 222, and sine 318 and 402 are all getting the same answer, except where they are positioned on the cost diagram. That's where we're going to look at something called reductions. Reductions means to make something smaller. So we're going to be able to see that big angles are going to have the equivalent value of a small angle. And there's certain formulas that we're going to work with to be able to figure out what that smaller angle is. We've always got to try and get down to an acute angle. So the easiest thing is just to let you see an example. But first I'm going to show you the full cost diagram. All right, so this is the full cost diagram. You've only learned the start of it, which was just the ASTC. But here's your 0, your 90, your 180, your 270, and then your 360. Quadrant 1, 2, 3, and 4. Still the same labels, all sine, tan, and cos. But what I've added on here is I've added on the 180 minus, the 180 plus, and the 360 minus. Okay, and then the theta and the 360 plus. I don't want you to worry too much about the all quadrant right now. I want to worry more about the sine, tan, and cos quadrant. So let's say I have an angle from the previous slide of 138. So if I think of it's 180 minus what will get me 138. Think of an acute angle. So now, if we were to subtract 138 from 180, we get 42. Now, that was the angle in the first column of our table. So it's saying that in this quadrant, we can take an angle like 138, use this formula, and it's going to get us an answer of 42. Those two angles then are equivalent. But now the issue is, when we're working in tans quadrant, if I use the angle from the third column in your table, 222, it's saying 180 plus what is going to get me 222. And again, it's going to be 42. So we can keep reducing these big angles down to the number 42 in this case. So because we're working in tans quadrant, sine is an enemy here. So it has to end up with a negative involved. So that's why my answer for sine 42 was negative in this quadrant. So sine 42 was negative 0.67, not positive. In the last column, or the second last column in your table, it was 318. So it's saying 360 minus something will get me 318. That something is 42. It's the common thread amongst all of these numbers. So the 42 is the acute angle that all of the others can be reduced. That's not reduced. Reduced. Okay, so we can take big angles like 138, 222, 318, and depending on the quadrant we're working in and the formula we're working with, it means that we can reduce them down to the angle of 42. Now, depending on if it's in sines quadrant, tans quadrant, or cos quadrant, cos would pump out a negative sine 42. It will be the same as sine 42, but the negative version of it, because we're in cos's enemy territory to sine. If we go greater than 360, so 402, it just means let's just chop off 360 and it gets us to 42. So we're going to work more with this. This is not the first and last time that you're going to see this. It's just easier if you see some of the examples as I go through them. Alright, so for example here, just in the corner, I'm just going to draw a little cos diagram. So all students talk crap. First quadrant, we use theta from 0 to 90. Theta is representing an acute angle, a small angle. Then from 90 to 180, it's sines quadrant. The formula we use is 180 minus theta. From 180 to 270, we use the formula in tans quadrant of 180 plus. And just think logically, 180 plus means it's after. We're adding on to 180. It's gone after 180. And then this is 360 minus theta. Okay, there are formulas involved that uses the 90 and the 270. At school level, though, we only teach you about the 90, not the 270 one. But we'll come back to that in a little bit. So I want you to ask yourself for each of these, because it says now for number one, write each of the following as a function value of an acute angle. Now that sounds like a mouthful, but it just means write it as a sine, cos, or tan, but of a small angle. So we're going to reduce this 312 into sine something. So you've got to keep the same ratio, sine, cos, or tan. So here it's a sine, it's got to stay sine. So ask yourself the question, where is 312? 312 is in quadrant 4. Okay, quadrant 4. For those who don't like Roman numerals, quadrant 4. All right, so it's in cos's quadrant. It's an enemy. So our answer must be negative. So now we have to ask ourselves, 360 minus what will get me 312? Now, often it's easier just to write 360 in your calculator minus 312. It is 48. So because we're in cos's enemy quadrant, we have negative sine 48. So in your calculators, quickly type in sine 312, and it gives you negative 0.743. Okay, so that's using the 312. Now, if I type in negative sine 48, it gets me the same answer. So you can use your calculators to check yourself on that. All right, so we can take a big angle and we can find an equivalent smaller angle with the same ratio, sine and sine, but because of where the bigger angle is, the equivalent is going to be a negative sine 48, so that we make sure our numbers match up. All right, we are going to do a lot more of these, so just bear with me, and obviously we are going to reteach it in class as well. Okay, so for the next one, tan 221. First question is, where is 221? It sits between 180 to 270, which is in tan's quadrant, which is good. Tan likes being in its own quadrant. It's going to be a positive answer. But we want to try and reduce it down to something smaller. So you've got to ask yourself, 180 plus what is going to give me 221? So that ends up being 41 degrees. So I can reduce tan 221, your final answer. I don't need the rest of this in your answer. I know it's going to be a positive answer, tan of 21. No, not 21, sorry. Tan of 41 degrees. So if you type in your calculator tan of 41 degrees, you get 0.87. If you type in tan of 221, you also get 0.87. So check that your answers match up. So tan of 221, a big angle, can be likened, it's equivalent to tan of 41. Think of the situation like when you have something like 1,000 over 2,000. That can be simplified. It can be reduced to a half. But we can also take 6 over 12 and also make it a half. So there's something, a big, ugly sort of fraction, and then another fraction that doesn't look too bad, and they can both be reduced to the same ratio. And that's the idea here. We're reducing it to the same angle ratio in order to work out a simpler answer. And it's going to make our lives a lot simpler when we get into more complicated questions. And you'll see a little bit more of why we're going to do it. All right, so moving on to 2a, it says evaluate each of the following without a calculator. Now, this word evaluate has value in it. They want a number answer. Now, without a calculator, first thing you think of is special angles. All right, so again, I know some of you are going to cheat and use your calculator for them, but don't let us know about it. So cos of 120 is not a special angle. It's also not acute, so we need to make it smaller. We've got to get an angle between 0 and 90. So ask yourself the question, where is 120? It is between 90 to 180, which is sine's quadrant, which means it's enemy territory for cos. We're going to get an answer that is negative. So ask yourself the question. For sine's quadrant, it's 180 minus something is going to get us 120. So it's 180 minus 60. But because we're working in enemy territory, we are going to get a negative answer. So when we write it out, the point is to keep the same ratio, cos, but because we're in enemy territory, we put a minus in front of it, it's negative, and we use the smaller angle that we've worked with. Again, in your calculator, you can type in cos 120, it gets you negative a half, and negative cos of 60 is also negative a half. So the negative stays here. The special angle for cos 60 is a half, and so we have negative a half as the answer. All right, so then tan 315. Where is 315? It's in cos's quadrant, which means it's negative, it's enemy territory, it's like gang warfare. All right, so you have to ask yourself, 360 minus what will get me to 315? So 360 minus 45. It has to be one of your special angles of 0, 30, 45, 60, or 90. So because it's tan, we're keeping the tan. Don't change it. We're just looking in cos's quadrant. So it's going to be a negative because we're in cos's quadrant. Tan stays, and we are working with 45 degrees. So the negative stays. We think, what is tan of 45? It is 1. So our answer is negative 1. Again, you can check on your calculator. Tan 315 is negative 1, and negative tan 45 is negative 1. All right, so now for number 3, evaluate without the use of a calculator. Again, that statement is saying to you, we're probably going to go special angles here. But we've got to reduce them first because our special angles are all acute. 0, 30, 45, 60, 90. So this 225 is far too big. So we need to reduce it. So sine squared 225. Don't worry about the squared. Just ask yourself, where is 225? It sits in tan's quadrant over here. So we know we're going to be getting a negative answer because sine will be negative in tan zone. And 180 plus what is going to get me 225? It's got to be a special angle. So it's going to be sine 45. But don't forget we're squaring it. So just stick the square on the outside. Deal with the sine 225. Isolate it, then put the square. So now, what is a negative squared? It is a positive, and that's going to be sine squared 45. Now, sine of 45 is a special angle of root 2 over 2, but don't forget we're squaring it. Now, when you're squaring an answer like this, remember your root is going to go away at the top. It's going to become 2 over 4, which when we simplify it is a half. It won't be negative a half because that negative over there was squared to become a positive. All right, last one on this slide. Hope you're keeping up. Otherwise, you can pause, rewind, go over it again. And remember, we are reteaching it in class. Sine 210 degrees plus cos squared 300 degrees. So sine 210. Where is 210? It's in tan's enemy quadrant. So we know we're going to get a negative answer for sine. 210, you've got to think what would be a special angle, 180 plus 30, but we're going to keep our sine. And then we look at what is cos 300. 300 is in cos's quadrant, which is great. And 360 minus 60 degrees will give us the same as the 300. All right, so then sine of 30 is a half, so we get negative a half here. And then cos of 60, you're going to see, is also a half. We'll come back to that idea later, but we're squaring it here. So negative a half plus a quarter is going to get us negative a quarter. All right, and you can check it by typing in your calculator sine 210 plus cos 300, and then you click the squared afterwards, and it gets me negative a quarter. So you can use your calculators to check, but not to get straight to the answer. We want the steps. We want to see your special angles. All right, so grade 11s, I'm going to stop with this video now, but if you want to practice some of the grade 10 Pythagoras and grade 10 basic trig that I revised in the previous video, you can look at exercise 1 on page 105 of your textbook. You can look at exercise 1 there. There's also a general recap. So recap on page 103 to 104 of the grade 10 stuff. So that's grade 10. But if you want to then practice some reductions, see if you're getting the hang of it, on page 106, going on to 108, there are some nice examples there of working with the reductions. I will go through some more reduction exercises once I've gone through the rest of the theory. I'll bring it all together and I'll put an extra worksheet or two up. But then you can look at the exercise and examples on page 108. So exercise 2 on page 108. And yeah, that's it, because then it goes on to the next topic. So If you're feeling a bit nervous about that, don't worry. I will walk you through the exercise 2 in another video, plus some extra examples of the reductions. Okay, so this is a brand new concept, so I'm not expecting you to just get it from one video, but have a look at the examples in your textbook and attempt the exercise. The exercise doesn't have number ones, it's practicing all your formulas. Right, so if you want to practice some of the number ones, you just have to wait for my extra worksheet, my extra examples, because the textbook's going to start mixing things. All right, so I'll put up an extra worksheet tomorrow, and I'll talk you through exercise 2 in a video tomorrow.